about? All right, now I think I'm recording. Yeah, okay. Sorry about that. So yeah, addition rule. So we said probability of A or B. All right, so that will be equal. We said it's equal to the probability of A plus probability of B minus probability of A and B. So minus probability of A and B. Right? And then the multiplication rule. So multiplication rule can be, sometimes it's tricky because there are like two cases, right? So we said, so if the two events A and B are independent, right? So if A and B are independent, so there are like two cases. So first case, so A and B are independent events. Okay, so then probability of A and B, we said that will be equal to the probability of A times, so this is a multiplication, right? Times the probability of B. So when you have A and B, that's a probability of A times multiplied by the probability of B. Now, if A and B are dependent, dependent. So again, just to remind you, dependent events means that, if the outcome of one event changes the other, right? So A and B are dependent. So if the outcome of A changes, the probability of B, for example, so are dependent, then this is probability of A and B. That will be equal to the probability of A times probability of B given A. So this bar right here means given. This means, so B given A. So given A means that A happened, okay? A occurred. So A occurred, okay? All right, so just to remind you of the rules we had last week. And then I think we started an exercise about the loyalty of customers, right, to a supermarket. I think, we didn't even start the first question, right?
We started the one about defective cameras.
Oh, no, the cameras. Okay. Oh, I did the cameras. Okay, that's for the dependent. Okay, thank you. All right, so this is then okay. So we can then probably do another exercise. All right, so yeah. All right, so I'm going to give you an example, guys, just to remind you how to compute all these probabilities, okay? And then I will give you a couple exercises because we need to practice a little bit in this section. Sometimes computing probabilities are not, sometimes it's not obvious, okay? So I'm going to give you an example and then I will go over some exercises in the textbook. So an example, let's see. Well, so let's say we have a survey of 100 students. 100 students, So this is an example exercise, let's say. So survey of 100 students, say at BCC. Okay, and then so we have the following results. So here we have female and male, female. Okay. And here, this is the number of freshmen. Let's say this is a sophomore, number of sophomores, right? And here, let's say a junior. And here, this is the number of seniors. All right, so let's say, for example, so we have 10 male freshmen. We have, let's say, 30 male sophomores. Then we have, let's say, 20 male juniors. And then let's say we have another 10 male seniors, okay? So this is, all right, probably I should take 200 students. Let's take 200 students instead of just 100. I take 200 students. All right, now for females, let's say freshman females, we have 40. So we have, for sophomores, let's say we have another, let's say we have 30. Okay, so here in total, we have like 140. And then for juniors, let's say here female junior, let's say we have another 40. And for female senior, let's say we have 20. Okay, so I mean, as you can see, the total guys, total number of students here, I mean, 10 plus 30 plus 20 plus 10, you know, plus 40 plus 30 plus 40 plus 20, that will be 200, right? So this is, yeah, so that'll be 200. All right, so for example, so using this survey, we're gonna try to find the probability that a student, of course, the student is selected at random or chosen at random, is, okay, one, female or junior. Two, female and junior. Three, junior, given that the student is a female, that she is a female. And four, so I'm going to switch junior and female. So female, given that she's junior. Okay. All right, guys. So yeah, so I'm gonna try to explain this example, and then of course next time I will give you an exercise, and I'm gonna give you some time to think about the exercise. But for this example, all right. So let's do this example together, okay? So for number one, so we have to find the probability that a student selected at random is actually female or junior, right? So female or junior, okay? I'm gonna call the event of, being female F, okay? And the event where the student is a junior, J, okay? So again, what I'm saying is that, so F, so let's say, so F, this is the event, the event in which, so the student is a female, right? And J, this is the event in which the student is, is a junior. So we have these two events, right? So F, this is the F is that's the event of being female, and J, that's the event of being a junior, right? So for example, for the first question, we are looking for the probability of female or junior. So this is like F or J, right? So this is like, so for number one, so it's the probability of F being a female. So F or, okay, so here, as you can see, so it's female or, so or junior. So or J, being a junior, that's J. All right, so we have these two events. So probability of F or J. Okay, so yeah, so F or J, or so this is probability of F or J, and this is exactly where we use the addition rule. Remember the addition rule? You have A and B two events. So then the probability of A or B, as you can see here, A or B, it's the probability of A plus probability of B plus probability of A and B, right? So I'm going to use the same, so instead of A and B, we have F and J, right? So probability of F or J. So this is probability of F or J. So so here we are using the addition rule. Right, so this is probability of A is F, so that's probability of F plus probability of B, but our B is J here, so probability of J minus probability of A and B, so that's probability of F and J. So probability of F and F and J. Right. So far so good. Any question, guys? Right. So what I did here, I just applied the addition rule, right? The addition rule we discussed last week. The probability of A or B, that's probability of A plus probability of B minus probability of A and B. And now instead of A and B, we have these two events, F and F or J, right? So that's probability of F plus probability of J minus probability of F and J, right? Okay, now we need to compute a couple of probabilities here, right? So this is probability of F. So what's the probability of F? F being a female, right? And the way we compute probability, guys, it's we have to divide the frequency of the event. So how many, in our case, the event is being a female, right? That's the event. So we count how many females, right? That's the frequency of our event. So how many students are females? Any guess? So how many students are female?
It's the sum of freshmen, sophomore, junior, and seniors.
Yes, that's the sum in the last in the second row, right? So this is this 40. We have 40 female freshmen, 30 sophomore female, plus 40 junior female, plus 20 senior female, right? So the sum of the last row, that will be exactly the total number of females. Yeah, thank you. Thank you, Janabu. Yeah. Excuse me?
It's 130.
Oh, yeah, absolutely, yeah. So it's 130, absolutely. Thank you. So, oops. So the number, so the number of females, that's 130. And again, this is the frequency. So how many, you count how many females, the students females, right? That's 130. And then we need to divide. So to compute the probability, we need to divide by the size of the sample, right? We divide by the size of the sample. So here we are interested in the students, right? So how many students in total? That will be our sample or size of the sample. So in total, we have 200 students, right? So we need to divide this 130 by 200. Okay. And whenever you compute a probability, guys, just we need to keep in mind. So the number in the denominator, the number in the bottom is always larger than the number in the top. Okay, that's because the probability is always a number between 0 and 1. Okay, so it's a number between 0 and 1, which means that the denominator is always larger than the numerator. Okay. All right, so this is for the first probability. Then we have probability of being a junior. Being junior, so what's the frequency of the event of being junior? We count how many juniors in total. So how many juniors, any guess?
40. 60.
Not 60, yes, thank you. So we are not just interested in junior female, right? We are interested in all the juniors, right? Male or female. So in total, we have 60, right? Because we have 20 male junior and we have 40 female junior. So in total, we have 60. So 60 juniors. So O plus 60 juniors. And again, that's divided by the size of the sample, which is, again, it's just 200 minus, and then we have probability of F and J. So F and J means being a female and being a junior. So the student is a female and a junior at the same time. Okay, so female and a junior and at the same time. So how many students are female and junior at the same time? Any guess?
80.
80. Why did you say 80?
Oh, I'm sorry. You said female and
Yeah, female and junior.
junior. Is it so it's gonna be
So yeah, female and junior at the same time. That will be the 40.
yeah.
This number here, this 40.
Oh, yes, 40.
So we have 40. So we have exactly 40 students who are female and junior at the same time. Okay. So female and junior, we have 40. So this is minus 40 over 200. All right, so then the probability would be, of course, that would be 130. So we have a common denominator. You keep the common denominator. So that's 130 plus 60 minus 40 over the 200. So that would be equal to 150.
230.
Yep. No, it's not 230. This is minus. It's minus 40. So 130 plus 60 minus 40, that will be 150 over 200. And if you divide 150 over 200, of course, that will be 70,
6. I mean 8.
No, 0.75.
Oh, yeah, it has to be 2 digits. Okay.
Yeah, 2 digits. So 2 digits after the dot. So that would be 75%. Okay. So what we are saying, guys, is that if you select a student at random, then there is a 75% chance that the student is a female or a junior. Okay. So that's like the interpretation of this 75%. And as you can see, guys, again, the probability, this is 0.75, which is the number between 0 and 1. It's less than 1, right? So it's a number between 0 and 1. And again, there is a 75% chance that the student selected at random is a female or a junior. Any question, guys? So you see how we apply the addition rule? F or J, so then that's probability of F plus probability of J minus probability of F and J. All right, so now for number 2, female, again, find the probability that a student chosen at random is a female and junior. So this is different from the previous question, of course, because now instead of or, we have and. So female and junior. So this student has to be a female and junior at the same time, okay? So, so female and junior. So probability of female and junior. So, so what will be the frequency of the event? So how many students in total are female and junior at the same time?
40.
40, right? Again, that's going to be the 40. That's the number of students who are female and junior at the same time. So that'll be 40 over, again, the size of the sample. Here, the student is selected at random. So we have 200 students. So this is a number of female and junior. And so here, this is the size of the sample. So in total, we have 200 students. That's the survey. It's a survey of 200 students. So we divide by 200. Anyway, so 40 over 200, that's 0.2. But we need 2 digits, right, after the dot. So that's 0.20, and that's 20%. Okay, so what we are saying is that there's a 20% chance that a student selected at random is a female and a junior. Any question, guys? So far, so good?
Yep.
Okay. All right. So now, now it's kind of tricky. I know this is sometimes it's not obvious. So here, number 3, we are looking for the probability that the student chosen at random is a junior, given that she's a female. So when we say that, given that she's a female, so we know that our student selected at random is a female. That's a fact. Okay, this is like a fact. We know that the student selected is a female. Okay, so in other words, we can just forget about the male students. Okay, we are just interested in the female because I know for a fact that the student selected at random is a female. Okay, so we can just forget about the males. Okay, and just focus on the females. All right. Now, so this is a probability of that the student is a junior, given that she's a female, right? So junior, so that's a probability of J, junior, probability of J, junior, given that she's a female. So the given that is this bar. Okay, so this is given that. So we know for a fact that the student is actually female. All right, so first we need the frequency of this event. All right, so as I said, because we know for a fact that the student is a female, we can just forget about the male students. Okay, we can just forget about the first, the first row. Okay, we're gonna just focus on the females, right? So now the question is, how many junior female? We forget about the males, right? So how many junior female?
40.
40, right? 40, absolutely. So here we're gonna have 40 over. Now, what's the sample in this case? As I said, because we know that the student is a female, right? So we can just forget about the male students and just we are just interested in the females, right? So how many females in total?
130.
130.
Yeah.
Yeah, that's the second row. That's the 40 plus 30 plus 40 plus 20. That's 130. So the 130, that's like the number of females, right? And again, because given that the student is female, it's a fact that she's a female. So we can just forget about the male. So we just focus on the females. So the total number of females, as you said, it's 130. So here we need to divide the 40 by 130, not by the 200. Okay. So you see the difference with the previous previous question, it's 40, right, over 40, because we know that's the number of female and junior. But here we divided by 200 because we don't know if the selected student is a female. We are looking for the probability that the selected student is going to be a female, but we don't know for a fact it's the student is a female, right? So here, that's why the size of the sample is 200, because the student selected at random, he or she is not necessarily female, right? In the 3, we know that the student is a female. Okay, so we can just forget about the males, and our sample is just given by the female students, right? So that's the difference between number 2 and 3. Okay. I mean, I hope this makes sense, because this is kind of tricky because I mean, it sounds like they're the same, but they are not. In number 2, we are looking for probability that the selected student is a female and junior. So we don't know for a fact that the student is a female, right? In 3, we know that the student is a female. So we can just forget about the total, the 200 students, and just focus on the females. And the number of females is 1/3. That's why we have to divide by 1/3 here in 3. Okay. And I mean, yeah. So this 40, of course, over 130. Let's see. This is actually equal to. Let me check my notes. Where's my notes? Okay. All right. This is equal to. Okay, 40. Where is the answer? Yes. So it's equal to 0.30. So this is 0.30, which is 30%. All right. Now, any guess for number 4? So number 4, where's number 4? So number 4, we are looking for the probability that a student chosen at random is female, given that she's a junior. Okay, so it's female given that she's a junior, right? So it's F bar J. So number 4, it's the probability of the student is a female given that bar that she is a junior, given that she's a junior. Okay. So here, what will be the sample here? we know that the student is a junior, right?
Mhm.
So if we know that the student is a junior, so we can just focus on, this column here. So my sample is given by juniors, just juniors, because I know that the student is a junior. It's given, right? It's a fact. So we can just focus on juniors, okay? Now, what's the size of the sample, or how many juniors do we have in total?
60.
60. So 60, that will be the size of the sample.
Example, yeah.
Okay, 60. So we need to divide by 60 because that's the total number of juniors.
Mhm.
So we divide by 60. Okay, because that's the number of juniors. Here we divide by 130 because that's the number of females. Right here is this bar. You can think of this bar like we divide by the number of females. Here we divide by the number of juniors. Okay, so 130, that's the number of females. And here, the 60, that's the number of juniors. So we over J, this is like over J, over the number of juniors. Now, how many females among the juniors?
14.
40, right? Again, 40, there are 40 female out of the 60. So this is 40. Again, 40. So we see, guys, 2, 3, and 4, and the questions 2, 3, and 4, the numerator is always 40. Because that's the number 40, that's the number of female and juniors. All right. Here, we divide by 200 because the student is just selected at random. Okay, we don't have any other information about the student. So the total number of students is 200. Now here we divide by 130 because we have one information about the student. We know that the student is a female. So we can just forget about the males, right? So we can just focus on the females. And total number of females, it's 130. That's why we divide by 130. And here, the information we have about the student is that he or she is a junior. So 60, that's the total number of juniors. Okay. And yeah, so then 40 over 60, of course, that's 2/3, and 2/3, that's 0.66. And the answer, let's say, is 66%. All right. I mean, I hope you see the difference between this F and J, J given F and F given J, right? So I know it's confusing the first time, but with the practice, a little bit of practice, you're probably gonna be okay. All right, so let's do, sorry, go ahead.
Yeah, I noticed that with this, you don't round up to the nearest whole number, and that's how it's supposed to be. We don't round up to the nearest whole number for this part, this section.
You mean like the answer?
Yeah,
I mean,
we don't.
no, it doesn't matter.
Doesn't matter.
No, it doesn't matter. I mean, for me, you're gonna get full credits either way.
Okay.
Yeah. All right, guys. So yeah, let me give you, well, at least let's do one exercise. At least one exercise. I mean, the time goes really fast, but let's practice at least. Let's do at least one exercise. So exercise number 2. So I guess I'm gonna, well, I don't know if you have the textbook, but this is from the textbook. Anyway, so I can, okay, let's see. All right, so, let's see. Okay, so this is, I think exercise, what? I think exercise 31, page 224. But anyway, so I'm gonna write out the exercise. So we have like, this is a survey of 2008 customers. Okay, and their loyalty to the supermarket based on location is given by the following table. So we have this is their loyalty to the supermarket based on their location. Okay. All right. You know what? Let's probably take a smaller number of customers, because I'm gonna just take instead of 2008, I'm gonna just take again 200 customers. Okay. All right. So so we have the following table. So we have customers from the east, from the south, let's say, and from the Midwest, right? And then from the, let's say, from the West. Okay, so the number of customers, they have been loyal for less to this supermarket for less than 1 year. So here, this is less than 1 year. This is from, let's say, from 1 to 10 years. And here, more than 10 years. So, for example, the number of customers from the east, and they have been loyal to the supermarket for less than 1 year, is actually equal to 20. Number of customers from the east, and they have been loyal to the supermarket from 1 to 10 years, is actually 30. And for more than 10 years from the east, we have 10. All right, so now we have another 10. This is here, it's 30. There's a 30 here. So from the Midwest, we have less customers. They have been loyal to this less than 1 year to this supermarket. So we have here, let's say 10. Here we have 10. This is 10, 20. So how many are there? 60, 70, 100. Yes, so here we have 5, and here we have 15. All right, so the total should be 200, if I'm not mistaken. So 60, 70, 100, 130. This is 160. Yes, that's correct. All right, guys. So in total, again, we have 200 customers. Let me just probably write here total number of customers is 200. Anyway, so the questions. All right. So first, so we have A or 1. So they have been, so of course, yeah. So we need to find the probability that a customer selected at random has been loyal for less than 1 year. So the customer selected at random has been loyal for less than 1 year. Less than 1 year. Okay. 2, a customer selected at random has been loyal at least 1 year. Okay. A customer selected at random, again, has been loyal for less than 1 year, given that he or she from the East. A customer selected at random has been loyal. So the probability that the customer has selected at random has been loyal. No, sorry, is actually from the East. Is from the East, given that he or she she has been loyal, or he has been loyal. Loyal for less than 1 year. Right. 5. Yeah, has been loyal for less than 1 year, and he or she is from the let's say from the South. Less than 1 year, and he or she is from well, let's say from the East again, from the East. All right. So let's say, guys, you have 5 minutes to think about this exercise. Okay. Okay, Kathleen, no problem. So to remind you again, guys, so this Wednesday we're gonna meet online because there is a heating problem in the campus. I mean, it's not just for our class, right? So if you have any hybrid or in-person class, then you're supposed to go online this week. Okay, Layla, let's see. So you are saying 25% for number one. 25. Yes, very good. Number two has been loyal at least 1 year. So that's 75%, absolutely. Given that he's from the East. So that's, yes, very good, Layla. Yes, that's correct. Okay. Oops, I'm sorry. What happened? I'm sorry about that. All right, guys, does anyone need more time? For number five, Laila, you are saying, is it 50%? And here's from the East. I don't think, no, I don't think it's, oops, come on. Sorry. So has been loyal for less than 1 year, and he or she is from the East. It should be 10% actually for number five.
Yeah, I think you're wrong. I had added up like I had added up East, South, Midwest, and West. That was my mistake.
Oh, okay.
Everything up from East.
Yeah, from the East. Yeah. Yeah. Yep. Right. Absolutely. Yeah. 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 All right, guys. Yeah. So so for number one, has been loyal for less than 1 year. So this is probably that the customer selected at random has been loyal less than 1 year. So yeah, first we need the frequency of the event. So how many customers in total they have been loyal less than 1 year? So less than 1 year, that will be the first column, right? This is the total in the first column. That's the number of customers that have been loyal less than 1 year. So that's like the 20 plus, plus 10, plus 10, plus 10, that will be 50, right? So we have 50 customers, they have been loyal to the supermarket for less than 1 year. So that's 50, right? Over, and then the customer is just a random customer. In total, we have 200 customers. So that's 200, right? So 5 over 200, well, that's 1/4, and 1/4 is 25%, is 0.25, so that's 25%. Number two. Please interrupt me, guys, if you have any question, all right? Has been loyal at least 1 year. So the key word here is at least. So when I say at least 1 year, it means the minimum is 1 year. So it could be 1 year or more than 1 year. Okay, so 1 year or more, that will be, from 1 to 10 years, right? From 1 to 10 years, or for more than 10 years. Okay, so again, at least 1 year. At least 1 year means that the minimum is 1 year. So it's 1 year or more than 1 year. 1 year or more, that will be from 1 to 10 years, the second column, or more than 10 years, that will be also the third column, right? So in total, we have, the second column plus the third column, we have 150. So we have 150 customers, 30 plus 30 plus 10 plus 20 plus 10 plus 30 plus 5 plus 15. So that's 150, right? 150 customers. They have been loyal at least 1 year. So at least 1 year, that's minimum is 1 year. So it could be 1 year or more than 1 year. So we have 150. So at least 1 year. So we have 150 customers that have been loyal at least 1 year. Over, of course, here the customer selected under them can be any customer. Okay, so that's 200 customers. So that's 150 over 200. That's a 3/4, and 3/4, that's 75%. Number 3, has been loyal for less than 1 year, given that he or she is from the East. Okay, so this is the probability that the customer has been loyal for less than 1 year. So less than 1 year, given that he or she is from the East. Okay. So given that he or she is from the East, it means that we know for a fact that the customer is from the East. Okay, so we can forget about all the other customers and just focus on the customers from the East. So from the East, we have, so our sample would be just customers from the East. And from the East, that will be the first row. And in total, as you can see, so in total, we have 60 customers from the East. Okay, so we need to divide by 60 because we know that the customer is from the East. and we have 60 customers from the East, right? So we need to divide by 60. That's the number of customers from the East. So it's customers from the East. Right? Now, out of the 60, how many have been loyal less than 1 year? Right? We are looking for the probability that this customer has been loyal less than 1 year, given that we know that he or she is from the East. So less than 1 year.
50.
Yes, less than 1 year, it's 20.
Oh,
Right? We have 20 because the customer is from the East, right? So we just focus on the customers from the East. And out of the 60, you know, the first row, we have 20 customers from the East. So that's 20. So it's 20 over 60. 20 over 60, that's 1/3, and that's the 0.33, which is 33%. 33 or 34%. Okay. Number 4. So this is the probability that the customer is from the East, given that he or she has been loyal for less than 1 year. So from the East, given that he or she has been loyal less than 1 year. So yeah, again, so we know that the customer, it's not just a random customer, it's a customer who has been loyal less than 1 year, right? So we are just interested in customers that have been loyal for less than 1 year. So for less than 1 year in total, we have, well, that will be that will be again the first column, right? And the first column, we have a total of 50 customers, right? They have been loyal for less than 1 year. So 50 customers, they have been loyal for less than 1 year. So we need to divide by 50, right? So this is the number of customers that have been loyal less than 1 year. Now, out of the 50 customers that have been loyal less than 1 year, how many are from the East?
20.
20, yes. We have 20 customers from the East who have been loyal for less than 1 year, so 20 so it's 20 over 50. Don't forget, guys, so the number in the top is always less than the number in the denominator. Okay, because the number the answer, it's always a number less than 1, right? So 20 over 50, that's for 0.4, and that will be 40%. Okay, and then for number 5, so for number 5, oops, so for number 5, so the customer selected at random has been loyal for less than 1 year, and, right? So the keyword here is and. Loyal for less than 1 year, and he is from the East. So again, here the customer is just a random customer, right? We don't know if he's from the East or if he has been loyal for less than 1 year, etc. Right? So it's just a random customer. It can be any customer, right? So in total here we have 200 customers, right? Now, out of the 200 customers, how many have been loyal for less than 1 year and he or she is from the East? Well, it's again 20, right? So we have 20 customers from the East and they have been loyal for less than 1 year. Okay, so that's 20 over the total number of customers. And so this is a probability of from the East, and he or she is she's been loyal less than 1 year. So that's 20, because we have 20 customers from the East and they have been loyal for less than 1 year over the total number of customers, right? Because again, the customer here is a random customer. We don't know if he's from the East or he has been loyal for less than 1 year, etc. Right? So don't know anything about the customer. So it's just a random customer. So it's the size of the sample. So the sample would be the 200, all the customers. So the 200 customers. So that's 20 over 200. That's 1/10. And 1/10 is just the 0.1, which is of course 0.10, and that's 10%. So number 5, actually the answer is 10%. All right. Any question, guys? I know. I mean, it seems like it's a kind of. It looks like a kind of confusing, but I mean, if you think about it a little bit, I mean, it's not. It makes sense, right? Okay. So, how much time? Oh, wow. Okay.
10 minutes.
You know, it's like we just have like enough time to do just probably one exercise or two. You know, it's crazy. I mean, the time really goes fast. I mean, and there's a lot of things to cover actually. But I want you know what, guys, I'm gonna give you another problem or another exercise. You can probably, I mean, if I don't know if I'm gonna have time to cover this, but if I don't, I mean, you can at least think about it. And of course, this week I'm gonna assign a new homework, so you will practice a little bit. Anyway, so let's say we have 12.5% of let's say New Yorkers are seniors. So what I mean by senior here, I mean 65, more than 65 years old. All right, and let's say we know that 14%, only 14% of seniors in New York get the flu shot. Get the flu shot each year, right? And we know that 24% of New Yorkers under 65, so of New Yorkers under 65 get the flu shot. Okay, so 12.5% of New Yorkers of the entire population are seniors. So they're plus 65 years old. Among the seniors in New York, only 14% actually get a flu shot each year. All right, and among them, under 65, we have 24% who get a flu shot. So yeah, so the question, guys, is the following. So A1, so what's the probability that a person selected a New Yorker, what's the probability that a New Yorker is under 65 and will get a flu shot each year. Get a flu shot each year. 2, Well, same question. So what's the probability that a New Yorker is actually is a senior and you know, and we'll get a flu shot each year and get a flu shot each year. So you have to read carefully this, you know, the question here. So I'm gonna. Oh well. Okay, 3 minutes left. All right. You know what, guys? I mean, you can think about this exercise, and then so next time I will go over this exercise, and then I guess I'm gonna start. I'm gonna move to the next section. And yeah.
The homework you will give the homework Wednesday, not today, right?
Yeah. I'm gonna give you the homework on Wednesday. Yes. Yeah. Yeah. So I'm gonna solve this next time, and then we'll start a new, I guess, new section. Yeah. I mean, as I said, guys, for this section, you need to practice a little bit. I'm gonna give you like a lot of exercises in the homework, but yeah. So you need a little bit of practice. Yeah. So yeah, I mean, I don't have time to solve this now. So I'm gonna just stop here, guys. And so I will see you on Wednesday online. Okay. So again, it's online on Wednesday. Yeah. So thank you for listening, guys. And I will see you on Wednesday. Thank you, everyone.
Thank you, Professor. Thank you. Bye.
Bye-bye. Bye-bye. See you next time. Take care.